Alright guys, you're welcome once again to my YouTube channel, and we continue with the BECE past question from 1990. So we ended with number 5. Now we continue from number 6 up to 15. So the question will be displayed on the screen. So there's the question for number 6. So with this particular question, we've got to divide. Okay, we are sharing 26,039 oranges equally among 13 women. That's what we are doing, and I would like to go with this particular method, scaffolding method of division. That's what I'm going to use to solve this particular one. So let's begin. So first of all, I'll draw this to guide me do the division over here. So we've got this. All right, so how many oranges are we sharing? We are sharing 26,039 oranges. We write that particular one over here. We are sharing it among 13 women. So 13 comes here. And then this is what we do. Think of any random number that when you multiply it by this 13, you get something closer to 26,039. All right, any random value. So I'll go for 1,000. All right, that particular one here. When I multiply 1,000 by 13, I get 13,000. So this multiplied by this will give me 13,000, and then I write it over here. I do a subtraction over here. 9 minus 0, we have 9. 3 minus 0, we have 3. 0 minus 0, we have 0. 6 minus 3, we have 3. 2 minus 1, we have 1. We continue using the same procedure. Think of any value that when you multiply it by 13, you will get something closer to 13,039. I will use the same 1,000 again. So 1,000 multiplies 13, we'll have the same 13,000 as we had over here. Find the difference. Now with the 39, what other value will be multiplied by 13 to give us 39? That value is 3. So when 3 multiplies 13, 3 times 3 gives us 9. 3, 1 gives us 3. We find the difference, we have 0, 0. This means that we have come to the end of the division. So the values that we have over here, we are supposed to add all of them, and that will give us the answer to question 6. So we have 1,000 over here. We add it to 1,000. We add it to 3. So 1,000 plus 1,000 will give us 2,000. Plus 3 will give us 2,003. That will be the sum of these 3 values. When you have 26,039 oranges and it is shared among 13 women, it means that each woman is going to receive 2,003 oranges. That is what we have right now. So the correct answer is 2,003. Go through the alternatives, whether it is A, B, C, or D. And the one that corresponds to 2,003 is the answer. So we are done with number 6. Let's box on to number 7. And the question is displayed on the screen right now. So the man gave his son 1 out of 2 of the money he withdrew from the bank. So let's write it over here to the son. The fraction the man gave to him was 1 out of 2. And then when we box on, we have the man giving the daughter 1 out of 3 of the same amount of money. So the man gave 1 out of 3 of the same amount of money. And then when the man was done, he had 500 cedis left. So amount of money left is 500 cedis. That was the amount of money left after he gave his son 1 out of 2 and the daughter 1 out of 3 of the amount of money he withdrew from the bank. So let's make some analysis over here. Let's compare and then contrast certain things over here. Now, for us to be able to find the amount of money the man withdrew from the bank, we will need to find the sum of the fraction of money the man gave to the son and the daughter. The sum of the fraction of money. So that's what we are going to do now. Sum of, and that will be 1 out of 2 plus 1 out of 3. Let's find the LCM to be 6. 2 divided 6, we have it to be 3. 3 1 will give you 3. 3 divided 6, you have 2. 2 1 will give you 2. So the sum of the fraction will give us 5. 3 plus 2, which is 5 out of 6. So the sum of fraction of money the man gave to both the son and the daughter is 5 out of 6. That's what we have right here. Good. Once we have the sum of fraction of money the man gave to the son and the daughter, we would need to find the fraction of money left. Okay, so let's find the fraction of money left. When we find the fraction of money left, it will be equivalent to, in monetary terms, the amount of money left. The fraction of money left will be equal to or equivalent to the amount of money left. So let's find the fraction of money left. Now, always bear in mind that the total fraction, okay, is equal to 1. So if you have the need, or there is the need for you to find the fraction left, always subtract the fraction that you have from a total of 1, because total fraction is equal to 1. So it will be 1 minus 5 out of 6. Still, we find the LCM and we have it to be 6. And then this one can be written as over 1. So when 1 divides 1, we have 1 divides 6, we have 6. 6 multiplies 1, we have 6. This one over here can be written as over 1. So when the 1 divides 6, you have it to be 6. The 6 multiplies 1, you have it to be 6. Then minus 6 divides 6, you have it to be 1. 1 multiplies 5, you have it to be 5. So if we proceed, 6 minus 5 will give us 1 out of this 6. So the fraction of money left is 1 out of 6. That's what we have. That is the fraction of money left. Now, since we have the amount of money left and the fraction of money left, it means that this and that are equivalent. So we can equate this to that. And then the total fraction is also 1. So let me list those ones down. So the fraction of money left, which is 1 out of 6, is equivalent to the amount of money left. So 1 out of 6 is equivalent to 500 cedis. So you have it to be 1 out of 6 equivalent to 500 cedis. Now, total fraction is also equal to 1. So the total fraction, which is 1, will also be equivalent to the total sum of money the man took from the bank. And the total sum of money the man took from the bank is not known. So we use any variable such as y to represent the total sum of money the man took from the bank. So from here, we cross multiply to find the value of y, which is representing the total amount of money the man took from the bank. So over here, 1 is going to multiply this, and then y will multiply 1 out of 6. So let's continue right from here. So 1 out of 6 multiplies y. And this will be equated to 1 multiplying 500 cedis. So right from here, when 1 multiplies 1 out of 6, we have it to be 1 out of 6y, which is equivalent to 1 multiplies 500, we have it to be 500 cedis. That's what we have. So from here, let's take it down. Now we have 1 out of 6y, which is equal to 500 cedis. So To continue, we have 1 out of 6y is equal to 500 cedis. I'm rewriting it again. So to find y, I'm going to divide both here and here by 1 out of 6 for us to find y. So we divide here by 1 out of 6, and then divide here also by 1 out of 6. This and this will be gone. So we have only y left over here. And then this means that we have 500 cedis divided by 1 out of 6. So it is 500 cedis divided by 1 out of 6. So y will be equal to 500 cedis. Then multiplied by the 6 goes up, 1 comes down, reciprocal. So 500 will multiply 6 all over 1. 6 over 1 is the same as 6. So right from here, we have y to be 500 cedis multiplied by 6 out of 1 is 6. Alright. And when we multiply 6 by 500, we have it to be 3,000. So this will give us 3,000 cedis. And that is it. We are done for question 7. So it means that the amount of money the man took from the bank was 3,000 cedis. Alright, so that's how we draw the curtains on question 7. Let's rush and then box on to question 8. We have this whole lot of question. 1 out of 2 outside the bracket, 1 whole number 1 out of 2 plus 3 out of 4 divided by 1 out of 4. So with this, there is common fraction. We have mixed fraction and proper fractions in there. So with this, we go by a method called BODMAS. All right, BODMAS, BODMAS. And with that, we solve the ones in the bracket first. The B means that bracket, and then the O means of, D means division, M means multiplication, A means addition, and then S means subtraction. So if there is a bracket, you make sure you solve the ones in the bracket first. So let's tackle the ones in the bracket first. So we have 1 out of 2, and then we change this to an improper fraction. Whenever you change a mixed fraction, you obtain an improper fraction. So 1 multiplies 2, and then we add it to 1. 1 multiplies 2, we have 2. 2 plus 1, we have 3. So we have to be 3 out of 2, then plus 3 out of 4 divided by 1 out of 4, bracket closed. So the ones in the brackets, that one we have addition and then division. So bracket of division, so we have to divide first. All right, we divide this first. When we are done, then we add the result or the quotient to 3 out of 2. So let's rewrite this whole thing again. 3 out of 2 plus 3 out of 4. That's how we divide. The division sign changes to multiplication. Then 4 goes up, 1 comes down. All right, we repeat this same thing over here. 3 out of 2 plus 3 multiplies 4. We have 12, or this 4 can divide this 4. So 4 can divide itself a single time. 4 can divide itself for a single time. So 3 multiplies 1, you have 3. Here we have 1. 1 multiplies 1, we have 1. Bracket closed. All right, so this is what we have, and then we can find the LCM of this. Now we can add before we multiply. So the LCM of 2 and 1 will be 2. 2 divides 2, we have 1. 1 multiplies 3, you have 3. We add it to 1 divides 2, you have 2. 2 multiplies 3, you have 6. So now we have 1 out of 2 outside the bracket. 3 plus 6 will give us 9, or out of 2. We box on over here. 1 multiplies 9, we have 9. And then 2 multiplies 2, we have 4. There is an improper fraction. If you are supposed to change it to a mixed fraction, 4 will divide 9 2 times. There will be a remainder of 1. It becomes the numerator of the common fraction all over the denominator, 4. So 2 multiplies 4, you have 8. 8 plus 1 is 9. 9 out of 4. All right. So 4 divides 9 2 whole times. Remainder 1 out of the denominator, 4. So this is the answer to the question. Question number 7. we are done with this, and then we box on to question number 9. Let's see how best we can solve this. Let me write the question down. So we are finding the value of x from this, and this under ratio, so we can express this as a common fraction, this also as a common fraction. That's one way of expressing ratio. So we have this to be 21 out of 2x, equivalent to 7 out of 10. So over here we cross multiply, 2x multiplies 7. So we have 2x multiplying 7, which is equal to 10 multiplying 21. All right, so this times this will give us 14x, which is equal to 10 multiplying 21. I don't want to multiply over here, so we write this whole thing again. This will give us 210. 14x will equal to 210. So to find x, divide here by this 14. To find x, divide here by 14, and divide here to by the same 14. All right, this divides this, and then you have only x left. So x will be equal to, when you come here, a common factor that can divide 14 and 210 will be 7. So let's go with 7. 7 divides is 2. 7 divides 21. You have it to be 3. 7 divides 0, and then you have 0. So you have 30 out of 2. 30 out of 2. And then when we box on, 2 divides itself a single time, and then 2 divides 30 15 times. So 15 out of 1 is the same as 15. That's what we have over here, 15. So the correct answer is 15 for number 9. So we are done with number 9. We box on to number 10. Let's take a look at question 10. The question is displayed on the screen. So let me write these preambles down. We have the length of AB, all right? (10 centimeters). The length of AX to be 4 centimeters. The question says we should find the ratio of the length of AX to the length of XB. Let's get the diagram drawn. So the question says from A to B, if you move from A over here up to B, it is measuring 10 centimeters. But if you move from A over here to X over here, it is 4 centimeters. All right, we know AX, the length of AX, which is what, 4 centimeters, but XB is not known from X to B. So from X over here to B is not known. But if you move from A to B, it measures 10 centimeters. And if you move from A to X, it is 4 centimeters. So what distance is it going to be when you move from X to B? If when you move from A to X, it is 4 centimeters, and the total distance or length is 10 centimeters. If you move from A to X and it is 4 centimeters, what will be the length of moving from X to B? What are you going to add up? What length are you going to add up to 4 to give you 10 centimeters? That is 6. So you subtract 4 centimeters from 10 centimeters, and that will give you what? 6 centimeters. So the length of XB will be equal to 10 centimeters minus 4 centimeters. And this will result in 6 centimeters. So that's the difference. That's the length of XB. So to find the length of AX to the length of SB, it will be AX, the length of AX, which is what, 4 centimeters, to the length of XB. XB is 6 centimeters now. So we have 4 to 6. That's what we have right now. Leave this in the simplest form. 2 is a common factor that can divide both 4 and 6. 2 divides 4, we have 2. 2 divides 6, we have 3. So we have the final answer to be 2 to 3. That is the final answer. So check from your alternatives whether 2 to 3 is there. We are done with question 10, and then we box on to looking at question 11. Let's take a look at question 11. The question will be displayed on the screen. So, percentage of candidates who passed. Let's write it down. And that is 60%. So the number of candidates who passed. Candidates who passed, that is 240 candidates. How many failed? That is the question. So we know the percentage of candidates who passed, and that is 60%. We know the number of candidates who passed, 240. These two are equivalent, okay? The two that we have there are equivalent. Now, there is the need for us to find the percentage of candidates who failed. Let's do that. Failed. So the percentage of candidates who failed is clear, and that will be 40%, because in totality, we have 100% of the candidates writing the examination. So if 60% passed, it means that the remaining 40% have failed. All right. So to find the percentage who failed, you subtract 60 from 100%. Okay. And that will give us 40%. So that's the number of percentage of candidates who failed. And then what about the number of candidates who failed? That's what the question is demanding that we find. So to find the number of candidates who failed, there is the need for us to equate these values that we have. All right. We don't know the number of candidates who failed. So we are going to represent that particular one using any variable such as A. So let A be the number of candidates failed. All right. So let's box on. This is what we have from here. Percentage of candidates who passed, which is 60%, is equivalent to 240 candidates. So we can equate that. So 60% is equal to 240 candidates. Now 40%, those who failed, 40% is also equivalent to the number of candidates who failed. Now that is A. Do we get it? So from here, we can cross multiply. So A will multiply 60. And we equate that one to 40 multiplying 240. So this is what we have from here. This will give us 60A. Let me write this same thing over here. 40 times 240. And then let me rewrite this same thing again. 40 times 240. Now to find the value of A, we need to divide here by 60. And divide here also by the same 60. So 60 divided 60. We have 1. So 1A, which is A. Alright. So A is equal to, we divide here by 10. We have 6. Divide here by 10. We have 24. Because this 0 will be gone. So we have 24 times 40 all over what? 6. And 6 divides itself a single time, divides 24. We have 4 times. 4 multiplies 40. You have 160 over 1. 160 over 1 is the same 160. So that's what we have from here. All right. 6 divides itself a single time, divides 24 4 times. So 4 multiplies 40, you have 160. 160 over 1 is the same as 160. So this is 160. So the number of candidates who failed will be 160. That's what we have over here. So question 11 is also solved. Let's box on and have a look at question 12. All right, so this is question 12. The question is displayed on the screen. So over here, the cost price of the table is 2,400 cedis. So let's write it down. Cost price is 2,400 cedis. And then selling price is 3,000 cedis. We are supposed to find the profit percent. But before we'll be able to find the profit percent, there is the need for us to find the profit. And to find the profit, it is equal to, so there's what we have, selling price minus the cost price. I'll use CP for the cost price. So we have SP minus CP. And then the selling price is 3,000 cedis minus the cost price, 2,400 cedis. Subtracting 2,400 from 3,000 will give us 600 cedis. We have the profits now, so we have to calculate for the profit percent. So let's box on profit percent. This will give us a formula: profit over the cost price times 100%. So to calculate, the profit is 600 now, 600 cedis over the cost price, which is 2,400 cedis, multiplied by what? 100%. Divide by 100, these 2 zeros will be gone. Divide here by 100, these two zeros will be gone. And then when you come down here, now you have 624. 6 divides itself a single time. 6 divides 24 4 times. Now you have 100 out of 4% left. And this will be equal to 4 divides 100, 25 times. So it is 25%. So if a table which cost 2,400 cedis was sold for 3,000 cedis, it means that the profit percent will be 25%. And that is it. We are done with question 12. We box on to question 13. So with question 13, the question will be displayed on the screen. And let me write the question down. There's under indices. The question says we have to calculate for the value of A. We find the value of A. So let's box on and then find the value of A. So A will be equal to, with indices, when you have the same bases, okay, and then they are multiplying, you add their power. So I will take one of the bases over here, and then I'll add 2 to 3. So 2 plus 3. Then I'll add the remaining values here. So this is what I have. 2 plus 3 will give me 5. 2 exponent 5 now, divided by 2 exponent 4. So 2 exponent 5 divided by 2 exponent 4. And the indices, they have the same base, and they are dividing. So we find the difference between the powers. So we have 2 exponent 5, then minus 4. So A will be equal to 5 minus 4 will give us 1, 2 exponent 1. And this will give us 2. When you have any non-zero value and it is raised to the power 1, the final answer gives you the base. All right, so over here the base is 2. So 2 exponent 1 will give us 2. And that is it. So the final answer is 2. So go through the alternatives. If you have 2 in there, you are gone. That is the correct answer. So let's box on to question 14. We are expressing a particular distance in standard form. The question will be displayed on the screen. Let me divide the space that I have over here, and let me write the distance down. We have 12,875 kilometers. So 12,875 kilometers, and we are expressing this in the standard form. Note this: whenever you are expressing a particular number or value, distance, any value in the standard form, this is what you are doing. You are leaving that particular value in a form that will have a whole number part and a decimal number part, and it is written using the powers of 10. All right, so with this particular value that we have, 12,875, let's take it for instance. If I have a value 1, okay, and it is 1.0, you bear with me that this same value is equal to 1. 1.0 is equal to 1. All right, if you have 2 or even 20.0, this is the same as 20. All right, good. So the decimal point actually doesn't matter that much. So if you have 20.0, is the same as 20. So when we come here, we have 12,875. So we can assume that there is a decimal point over here. If it is 0.0, it is this same value. It doesn't change anything. And if you are moving to the left, increasing the positive powers of what? 10. That's what we are doing. When we are moving to the left, that's what we are doing. So if we move from here to here, it means we have multiplied this by 10. It means now the decimal point is here. We have multiplied it by 10 exponent 1. Then we move it a second time. It is times 10 exponent 2. A third time times 10 exponent 3. The fourth time times 10 exponent 4. So this is what we have right here. 1.2875 multiplied by 10 exponent 4. Listen, with standard form, you only leave the first value. Okay, the first value shouldn't be more than 9. It shouldn't be a two-digit number. That is it. So the whole number part is supposed to be a single digit. Then the decimal point comes, and then you have the decimal values multiplied by the powers of 10. I believe you have followed that particular one. So this is the answer. Expressing 12,875 kilometers in standard form is 1.2875 multiplied by 10 exponent 4. Because we moved to the left 4 times, it is times 10 exponent 4. All right. If you get a different question and you are moving to the right 4 times, it means it will be times 10 exponent negative 4. That is when you are moving to the right. Then it means it is increasing with negative powers of 10. But if you are moving to the left, it means it is increasing with positive powers of what? 10. Please note this. So this is the final answer to question 14. Now let's box on and have a look at question 15. All right, guys. So with number 15, the question demands that we find the fraction of Mr. Ewo's income spent on food. When you take a look at the pie chart, all right, you have with the sector for food, the angle over there is 120 degrees and the total sectorial angle is 360. So that is how we find the fraction. It will be the sectorial angle for food out of the total sectorial angle. So this is how we go about it. Sectorial angle for food. The sectorial angle of food will give us 120 degrees. That is from the pie chart. The sectorial angle of food is 120 degrees. The total sectorial angle is 360. When you take the whole circle, the total sectorial angle is equal to 360 degrees. So let's put that particular one down. Now let's find the fraction of income spent on food. So the fraction of income spent on food will be equal to the sectorial angle of food over or out of the total sectorial angle. So we have it to be 120 degrees out of 360 degrees. And when we divide here by 10, we will have 12 left. We divide here by the same 10, we have 36 left. And we divide here by 12, we have 1 left. And we divide here by 12, we have 3 left. So the final answer is 1 out of 3. So the fraction of Mr. O's income spent on food is 1 out of 3. That is that. So we are done for question 15.